So hi, this is a very difficult to route backplane I made in KiCad. And so instead of just like routing it, I decided to write my own auto router. So this is OrthoRoute. It's a KiCad plugin. It's GPU accelerated and it's very fast. So I'm going to go ahead and click auto routing and talk about it while it's working. I'm also going to do a clock here that's real time. Fix it in post. The basic idea behind this auto router is that we create a grid of traces on multiple layers. The top layer, which you just saw get there, is dedicated to escape planning, and below that, the next layer is an array of horizontal traces. Below that is an array of vertical traces, and this continues until we get down to the bottom layer of the board. To find a path for the air wires, we're borrowing an algorithm from FPGA. Specifically Pathfinder 1995, and this is an algorithm that is congestion-aware routing through a Manhattan-style grid. So this is an iterative process. You just saw iteration 1 pop up. The first iteration is purely greedy routing. Iterations after that take into account the overuse of each edge of the graph, history, pressure factors, and layer transition is done by blind and buried vias. So I'm going to speed this up until this is done. That is a real-time clock that I'm going to put in post. Hey, so there we go. Routing converged with 3,000 tracks and 1,500 vias placed. So I am going to import this into KiCad. Yes, it is. Anyway, here's a version that has KiCad, or imported into KiCad, and yeah, it is acceptable. This right here, boom, we get a view of what the traces look like in there. So this is the Pathfinder algorithm in action. This is how FPGAs are programmed. So included in this video are links to the GitHub repo and the project write-up. Subscribe and follow me on X, the Everything app. There will never be a Discord of this project, but if you're interested, issues and pull requests on GitHub, welcome.